Okay. Da-da. I need another cable. This cable's junk. Not the right one. Okay. Let's see what I can find. See, maybe there's one in the car. Okay, I got lag. What's this lag for? Okay, I'm using 36 CPU, 19 frames per second. That's trash. 60 frames. Okay, it's 24 frames. Still trash. Let's restart it. Start streaming. Better. Okay. All right. We're at 45 frames. That is at least 60 FPS. Either way. Okay, we're going to start with this guy. Then move on to here. I'm not going to have the zoom in issue, am I? No zoom in issue. Okay. Get some scissors first. Card stop. is yours. Let's do this. Aha. Uh-oh, what do we got going on here? Do. Got two. Unlisted. Oh no, we can't have unlisted. Let's list this sucker. It's all fine. The logo though. Got to change. You know what? There we go. Back to cut and paste. All right. Alright, let's see what does this look like. Get the intro going on. Main, which is my dirty house in the background, and the document camera, but it's not even straight. There we go. And now it's way off. Now the streaming, that's a lag, but the recording is good. Okay. All right. It's about time to get this thing started. We shouldn't have any lag going on here. No lag. No lag. Here, okay, we have sound there. We have sound here. Welcome. Okay, today we're going to start working on chemical changes, or what are indications of a chemical change has occurred. All right, so as we go through this video, you're going to see some questions that pop up on your screen. I need you to answer those questions as you go along. You will not be able to progress to the next assignment until you actually scored a certain amount of those questions correctly. If you don't score those amount correctly, you have to go back and redo this video until you get that percentage. All right, so we got this cool little diagram here. And we use this diagram to help us identify indications of a chemical change has occurred. So first thing, on chemical changes, if we ever have a new substance being formed, we have a chemical change. But sometimes it's just not that easy. You can't tell just right away a new substance has occurred. So we use this diagram here to break down each piece on how do we actually identify those. So other identifiers, we have, let me zoom in here, you see it, color. If we see a color change has occurred, a chemical change may have occurred. Doesn't mean it have, but it may have occurred. If we have gas or odor present, a chemical change may have occurred. If we have a light present, a chemical change could have occurred. Temperature, if it got hotter or colder because of a reaction, then a temperature change has occurred. Not just because it got hot or cold, because a reaction caused it. So if you put a pot of water on the stove, try to make some noodles, and you turn the stove on, the water heating up is not an indication, you're just heating up the water. But if it just grabs something and starts heating up because you added some chemicals to it, then yeah, it's probably a chemical change. And the last one, precipitate. Next, the color, if you have switching colors. Gas, if it has like bubbles forming or there's a smell to it. Light, such as like fire being produced, or glow stick. Temperature, if it's increasing or decreasing because you made a reaction. A precipitate is where you mix some liquids and solids form out of those liquids. So we have these 1, 2, 3, 4, 5, 6 scenarios. Let's look at each one of these scenarios and try to identify if a chemical change has occurred. Now remember, if we have on our stuff and tells us a new substance has formed, then we automatically know chemical change has occurred. This is for if that's not given. So we're going to look at this first hexagon here. So we have, looks like fireworks, actually a glowing star, fireworks, leaves changing colors for the fall, and glow sticks. So if you look at the glow sticks, usually like orange color, but whenever you pop them, they do get hotter. And I just messed up there. Oh, great. Sorry, I got a new document camera. My other camera broke. All right, I gotta switch cameras. There is a lag on this thing, and I'm not doing that lag. So let's see what we can do here. When the iPhones fail, you bring out the old school cameras on a stick. Okay. So this thing apparently isn't working right. So I'm going to redo the whole thing. Trash. Okay. Got this thing. Get rid of this mount. Now, the thing is, I don't like this camera because it is a zoom in and out thing, which is really annoying. I wish I could turn the auto zoom off of it, but whatever. Okay. Let's see here. All right, there we go. But it's upside down. Okay. Chords. See, that's why I don't hate that. There we go. Okay. That stinks. Now I can't zoom in close. welcome. So today we're going to work on chemical changes and how do we know a chemical change has occurred. So usually in everyday life we deal with these all the time, but this is going to help us identify that a new substance be formed. So as we go through this video, you can have some questions pop up on your screen. In order to progress to the next assignment, you must score a certain amount on this assignment in order to move along. If you don't score that amount, a new assignment will not appear and you have to redo the assignment until you get that needed score. All right, so in order to figure out if a chemical change has occurred, we're going to use these items right here to help us out. Okay? Before we even think about these items, if we're told, hey, a new substance has formed, then we already know a chemical change has occurred. But it's not always that easy. So we're going to use a couple things to help us remember on if it occurred or not. So if we ever see a color change, so it goes from, say, green to blue, it may be a chemical change. It does not mean one has occurred, but it may have occurred. Remember, also something new has to be present. If there's a gas like bubbles or smells, it may be a chemical change. If light is being produced, it may be a chemical change. Not always, but maybe. If you just turn a light switch on, is that a chemical change occurring? No. But maybe you strike a match and you see flame happening and it's producing light. In that case, it would be. If it gets hot or cold, it may be a chemical change. Now, if you just throw a pot of water on the stove to make some noodles and it gets hot, you just turn the gas on, that's not a chemical change. That's just heating it up. But again, let's use the scenario of the match. You light it up, you strike it, it's forming an oxide on the end, and it's getting hot. So in that case, it would be a chemical change. The last one, it's probably my favorite, is the precipitates. It's where we have two liquids, we mix it, and we're forming a solid. All right, so let's look at these pictures real quick, try to help us identify these items. In this picture here, I have some glow sticks, some fireworks, some leaves that are changing color because it's fall, and those starfish that are deep in the ocean. So glow sticks, if we snap those, they will actually start producing light, but also color. It goes from like a clear to a green, sometimes a light blue to a really bright blue. There's a color change happening, so that's indication of a chemical change. So that's going to be color. All right. The next one we're going to use, actually let's keep on going with these. So we have leaves. So leaves are usually green, but in the fall time, they start fading and change to different colors because they're dying off and the composition of that leaf is changing. So because the composition is changing, a new substance is occurring. So that means these are a chemical change. It went from green to this yellow to red and orange, and eventually to black and brown and nasty. So that's a chemical change. We have fireworks. So sometimes like potassium permanganate is put in fireworks. It's like a grayish color. When it ignites, it's changing colors like these bright reds and blues. Actually, potassium permanganate is usually purple. So it's going to be those different colors. It's changing color, so it's going to be an indication of a chemical change has occurred. All right. The next one here is a Statue of Liberty. So it is copper, or is it brass? I can't remember if it's copper or brass. Either way. It's this color originally, and over time it oxidizes and creates this blue color here. It's changing color because there's oxidation happening, or it's kind of similar to rusting. So that color change, it tells you a chemical change is occurring because there's like a film on the outside, which is oxidation. So there's going to be a color change. Also, it is forming a new substance. It's forming an oxide, which is that new substance. The next one here, we have an awesome skunk. So the skunk, we really can't see it, but it's visualized by these little waves up here. It has a smell to it, an odor. So we see that odor, and it's about, ooh, it's stinky. It may be indication of a chemical change. Down here, and sorry, these are kind of cut off, but we have two test tubes that are clear, and they are mixed together, and they form this. So we still have a liquid here, but we have a solid forming, like a solid jelly substance. This will be our precipitate. So that's an indication a substance has a chemical change has occurred. A new substance has formed. So let me put odor here. gas. Okay. The next one we have a match being struck. So before the match is struck, it has a green tip at the end and a stick. As soon as you ignite it, we see a flame, which is going to get hot. So this will be a temperature change. We see light being produced. So as you strike a match lighted candle, because it's dark inside there, you can't see. Strike a match, you can see it. So we have some light. You see some, this right here, this little smoke representing gas. Also, we can smell that match. After you light a match, it stinks, so we have an odor. And a color change. So you can't see it yet, but when that match burns out, it went from a green to a black. It's formed like a carbon deposit, so something new. So that would definitely be color. Let's look at this last one here. So we have here a liquid. It's more likely probably vinegar or acetic acid and a piece of chalk. They're going to drop this piece of chalk in that vinegar, and it's going to form this. It's going to have bubbles. It's a little difficult to see on here, but there's little bubbles being formed. It's making gas. So there's a gas being formed. So, and also it would stink. It actually smells like a Sprite when you first open it up. There's also an odor. So that's an indication of a chemical change. So if we see these items here, or if we ever just say that, hey, a new substance has formed, we have indication of a chemical change has occurred. Now I'm going to work some couple practice problems here. On these practice problems, you're going to see some questions pop up on your screen. I'm going to need you to answer those as we go along. And I've lost my first one. Oh, I actually put it down there. Let me grab it real quick. Okay. And it's going to be hard to see there, so let me try to zoom in this camera a little bit. All right. Sorry, it's not the best setup here, but okay. So we have methane, CH4, as combustible substance that will burn in the presence of oxygen. Once methane burns, carbon dioxide will remain. Which statement indicates that a chemical reaction has occurred when methane burns? All right, before we do anything, you can see a question pop up on your screen. I need you to identify, what is this question asking? Great. I'm hoping you said which statement indicates that a chemical reaction has occurred when methane burns. So the key part is which statement indicates that a chemical reaction has occurred. So we're going to have to look at each one of these and figure out which one is correct. Let's look at A. Methane contains carbon and oxygen. You're going to see some questions pop up on your screen. I want you to tell me, why is this one correct or not correct? Great. Let's look at the next one here. Carbon dioxide and water are produced. So I want you to tell me which key word on this tells us that this is the correct answer. Fantastic. Even though we know this is the correct answer, let's move on to the next one and figure out why these are not correct. So methane is a compound. Great. Oxygen is required for combustion. Now combustion tells us that we're going to have like a fire, but why is this not the correct answer? Fantastic. Let's move on to the next one. A science teacher performed a demonstration for her students. Wearing protective gear, she began putting 50 grams of sugar in a beaker. Next, she carefully poured 20 milliliters of sulfuric acid into the beaker. After approximately 1 minute, smoke appeared on the sugar and a solid. A black column of carbon slowly rose in the beaker. We have a diagram here. We see sulfuric acid being poured into a vial of sugar. It's a little hard to see here, but there's little sugar granules here. It's faded away. After that happened, we can see that there's a little bit of liquid going on here. course, because of the sulfuric acid, some chunks happening. Then it's going to progress to this. The teacher stated that a chemical reaction occurred. Which evidence supports her statement? So real quick, what is the question actually asking? Looking at the question that's popping on the screen now, please tell me. Fantastic. Now let's look at each one of these. I want you to tell me if they're correct, or why they're correct, or why they're incorrect. F. The teacher used 50 grams of sugar and 20 milliliters of sulfuric acid. Does that statement, is it correct? Or does it support her statement, or does it not? G. The smoke changed color and a column form appeared. Does that support the teacher's statement that evidence that a chemical reaction has occurred? H. The sugar turned slushy when the sulfuric acid was poured into it. Does that right there support the teacher's statement that a chemical reaction has occurred? And J. The teacher put on protective gear before performing the demonstration. Does that statement support the teacher's claim that a chemical reaction has occurred? Fantastic. Let's go ahead and move on. Jody wanted to bake a birthday cake. Using a recipe, she placed the specific amounts of flour, sugar, butter, eggs, milk, chocolate, baking soda, and vanilla into a bowl. That's a lot. She mixed the ingredients together and baked the cake at 350 degrees Fahrenheit for 45 minutes. After removing the cake and allowing it to cool, she then spread chocolate icing onto the cake. During which step in this process did a chemical reaction occur? So tell me real quick, what is the question that's being asked here? Awesome. So now let's go through each one of these and determine if an item supports the question or if it does not. A. Putting the ingredients into the bowl. Does this response support the question? B. Mixing the ingredients with an electric mixer. Does this question support, or this response support the question? C. Baking the cake in the oven. Does this question support, again, I give my same question, does this response support the question that's being asked? Last one, D. Icing the cake once it's cooled. Again, would this be correct or incorrect, and why? Okay, so during which step of the process did a chemical reaction occur? A, putting the ingredients in a bowl. So we're just mixing. So that's mixing. Did any of those indications occur, like color change, gas, light, temperature? No, it did not. Because we're just mixing. We're putting them together. So no. Mixing the ingredients with an electric mixer. So again, we're just mixing. We're not really doing anything. No indication is present. Baking the cake in the oven. Okay. Well, this doesn't say that a chemical reaction is occurring, but we got to think back in our heads. When we bake a cake, what happens? We put it as a liquid. It goes in the oven. It comes out. It's nice and fluffy. But why is it nice and fluffy? It has those air bubbles in there, right? Well, that's because of a gas has been produced. Because that gas is produced, that means a chemical change has occurred. And also, you can smell the cake when you're baking it. It smells really delicious. That's an odor that's also happening. So that right there is a good indication a chemical change has occurred. But let's still check out D, and just to make sure we're right. Icing the cake once it has cooled. Okay, so cooled is talking about temperature change. It's just getting colder. But is that from a new substance being formed? No. So that's kind of a tricky one there. So that's not it. So what we're doing is just making it look beautiful. But that's not actually making a chemical reaction. So we're definitely going to say C, baking the cake in the oven. All right, let's get second video ready to go. All right, let's work on the next couple sets of problems. So a group of students completed an experiment. The students added 5 grams of white powder of NaHCO3 to the corner of a plastic bag, and 5 grams of another white powder, CaCl2, to another corner of a plastic bag. Next, they poured 10 milliliters of phenol red solution into a small plastic cup and placed it inside the bag. Being careful not to spill the liquid, once the bag was sealed, the students allowed the phenol red solution to mix with the other powders and recorded their observations in the table. Let's read the observations. Roman numeral 1, one powder is thicker and chunkier than the other powder when dry. 2, the liquid is dark red in color before mixing with powders. 3, once the substance was combined, the mixtures turned orange. Roman numeral 4, the bubbles form in the orange mixture and gas collects in the bag. Number 5, one corner of the bag feels warm, and the other corner of the bag feels cold. Which observations during the experiment show the evidence that a chemical reaction has occurred? You can see a question pop up on your screen, and go ahead and tell me, what is this question asking? Fantastic. So from analyzing this, we see which observations during the experiment show evidence that a chemical reaction has occurred. So we're looking for which of these experiments show evidence of a chemical reaction. So evidence, again, is like we have color change. We have gas being produced. We have light, temperature. And the last one, where we mix 2 liquids together and we get a solid, would be a precipitate. Okay, so we have F, which is 1, 2, and 3, G, 2, 3, 4. Let's go through each one of these and see. So statements 1, 2, and 3 from F. Well, let's see, 1 is one powder is thicker and chunkier than the other when dry. 2, the liquid dark. Okay, so as we see here, this may be a lot of reading. So let's stop here and let's take a look at each one of these and mark them chemical change or not. So one powder is thicker and chunkier than the other powder when dry. So that's describing physical properties. That's physical properties. So would this be indication of chemical changes occurred? No, definitely would not. Number 2, the liquid is dark red in color before it mixes with powders. Okay, so we have a maybe, so a liquid is dark red in color before it mixes with powder. Did it say that it did change color? It didn't say it, but also that might be maybe like a hint. So I can put a little line there that is just in case, like maybe the way it's wording is kind of tricky. Number 3, once the substances are combined, the mixture turns orange. Okay, so we have the word combined here, they mix, and it turns orange. So this is a color change, we know that for sure. So that's indication. Bubbles form in the orange mixture and gas collects in the bag. So which words in this sentence right here tells us that a chemical change may have occurred? You should see this pop on your screen right now. Great. I'm hoping you said that bubbles formed and gas collects. That bubbles form and gas collects. So that's going to be a gas or odor. Number 5. One corner of the bag feels warm or the other one feels cold. Okay. So that may be one, because, I mean, if they start off the same temperature, reading the question, and now they're changing. See, so it feels warm, the other one feels cold. Doesn't mean it has occurred, but maybe. I'm going to put temp. Okay. So we know one's already gone all the way 2 is a maybe. Probably not, but could be. 3, 4, and 5. Okay, let's read each one. So F, statements 1, 2, and 3. Did those have these indications up there? Well, it has 1 on there. So this is trash. That's a maybe. We know that one's good. So, but that's that one there. So it's automatically gone. There's statement 2, or G. Statements 2, 3, and 4. Is that one correct? Does that show an evidence of chemical change? Okay, we have that 2 there. That's a maybe. We're not sure, so put a line there next to it. We'll come back. Let's look at H. We have statements 1, 3, and 5. Again, we have that 1 here, so we know that's going to be a no-no. Remember, because it's just descriptions. And J, statements 3, 4, and 5. Well, 3 says we combine to an orange, 4 is bubbles being formed, and 5 is warm and cold. So we have G and J. You can see a question pop up on your screen. I want you to tell me which one's correct and select one that has the best reasons why that would be correct. Great. Let's move on to this next question right here. Johnny was playing in the yard when a bee stung his arm. Ouch. To ease the pain, his mother gathered baking soda, vinegar, and water in a spoon. She combined the baking soda with water until it was the consistency of paste. She then smoothed the baking soda paste over the sting area. Next, she slowly dropped vinegar on the baking soda paste. Bubbles began to form, and eventually Johnny's pain subsided. At which stage of the procedure did a chemical reaction occur? So you can see a question pop up on your screen. What question is being asked here? Fantastic. Now, I want you to mark on your own piece of paper on the side on what important information is being present. Then let's go through each one and see, is that right or wrong? So A, water was added to the baking soda to form a paste. Is that evidence for a chemical reaction occurring? B, the baking soda paste was smooth onto the sting area. So again, question is going to pop up on your screen right now. Does that give us an indication that a chemical change has occurred? C, drops of vinegar formed bubbles onto the paste. Again, you'll see a question on your screen. Tell me which one of those responses best justifies this being correct or incorrect. And D, the pure vinegar had a strong smell. Again, does this have any evidence for the question? You can see that pop on your screen, provided the correct answer choice. Next one. Okay. Most plants produce their own food through a process of photosynthesis. During this chemical reaction, carbon dioxide and water use energy from sunlight to produce glucose and release oxygen. Which statement provides evidence that a chemical reaction occurs during photosynthesis? So you're going to see a question pop up on the screen. Tell me what part of this tells us what question is being asked here that you would mark when given an assessment. What would you mark and underline? Great. Now let's look at this diagram. What actually is this diagram telling us? Of course, we see a flower here. We see C6H12O6. Some different items here. You can see a question on the screen. Out of those responses, which one correctly tells us what this diagram is actually telling us? Okay. Now let's look at each of these responses and let's break them down and see, do they actually answer the question? Remember, the question is, which statements provide evidence that a chemical reaction has occurred during photosynthesis? So we're looking at each statement, the evidence, and a chemical reaction. So let's review those one more time. if we have a color change, if we have gas being produced, or maybe even an odor. Then we also have light being produced. If we have a temperature change, or even a precipitate, which is liquids forming solids. So out of these items, do these actually have any evidence that chemical changes occurred? So F, glucose has different properties than carbon dioxide and water. Again, you're going to see this on the screen. Fantastic. G, carbon dioxide, water, and glucose could contain carbon, oxygen, and hydrogen. Using the question on your screen, it's going to pop up right now. Okay. H, the reactants and products have the same number of atoms. J, water is absorbed by the xylem in the roots. Does that provide any any evidence that a chemical reaction has occurred? Fantastic. All right, now that we completed this video, make sure you hit the submit quiz at the end of the video. And if you have actually scored the amount you needed, another assignment will pop up for you. If the assignment does not appear, that means you need to watch this video one more time, completing the questions, to get the higher score. You must have a certain score before you can move on to the next assignment. Oh, phone. Alrighty. Took an hour for a 6-minute video. All right. Breakfast time.